Can our cities be dense, sustainable, and resilient? Hi, I'm Peter Ortner, Assistant Professor for Architecture and Sustainable Design at SUTD. In this lecture, I will share with you some reasons that our densest cities may be inherently less resilient to external shocks, like the ongoing COVID-19 epidemic, and also some ideas for how we can begin to address this challenge. Dense cities are efficient in terms of land use, efficient in transportation, efficient in energy use. And because of this efficiency, many studies show that their residents contribute fewer greenhouse gases per capita. As an extension of this point, we are familiar with two additional claims. One, that dense cities are sustainable, and even two, that dense cities can be a tool for combating climate change. The question I would like to raise in this lecture is if this efficiency of urban density may come at the expense of resilience. Raising efficiency inescapably lowers resilience. This is the claim of systems engineer Dennis Meadows, co-author of the 1972 Limits to Growth report. This claim comes from a recent article where Meadows explains some of the root causes of the COVID-19 epidemic. With his statement, Meadows defines a very pessimistic zero-sum game for the 21st century. We can only fight the effects of climate change with increases in efficiency, but each time we increase efficiency, we make ourselves less resilient, more vulnerable to the shocks of a collapsing biosphere. The bigger question I will ask in this lecture is, what space of opportunity exists for our 21st century cities, if any, in trade-offs between sustainable efficiency and resilience? Meadows' claim builds on his definition of resilience. Resilience is the capacity to experience an interruption in the supply of required input without suffering a serious permanent decline in the desired output. This is a systems thinking definition of resilience, but I would suggest it is a good place for us, as architects, as urban designers, to start in our discussion, especially if we accept that our modern dense cities are complex systems of interconnected flows, and that the study of urban resilience is an effort to understand if, how, and when these complex systems may collapse. If we accept for now the proposition that raising efficiency inescapably lowers resilience, we can go on to make two claims. The first claim is predictive. Regardless what the next external shock will be, and it seems there may be many in this century, we can make a claim about what cities, or parts of cities, will be least resilient. Urban systems where efficiency has been taken to an extreme are less resilient. That is, more vulnerable to disruption. One question I've been asked to answer today is what external shocks could happen in my region. Of course, I could make some guesses about this, but I would probably be wrong. However, if we could link vulnerability with a type of urban development, then we don't need a crystal ball to know if we need to look out for drought, or war, or pandemic. We could assess vulnerability independent of threat and make changes accordingly. The second claim is powerful in terms of the challenges and opportunities it opens for urban design and architecture. If highly efficient urban systems are vulnerable to shock, then the ability to understand trade-offs between this efficiency and resilience with enough specificity to support planning and design can make it possible to create cities that are both dense and resilient. As an architect, I'm enticed by the proposition that we may strategically choose to subvert efficiency in order to grow resilience, as it suggests an opportunity for an architectural maximalism to come into play relative to the dual minimizing influences of sustainable efficiency and economic efficiency. This is especially the case if we refuse a definition of urban resilience that relies exclusively on robustness of our engineering, and instead also captures how our built environment contributes to the human resilience of our cities. In this lecture, I will present some anecdotes from recent research on COVID-19 and the built environment in Singapore. I hope it can contribute to a movement to grow our knowledge on how properly designed cities can support not only resilient infrastructures, but also, and especially, resilient human communities. I'm joining you from Singapore, one of the world's densest nations. Though you may be familiar with this image of Singapore, for the vast majority of its nearly 6 million residents, Singapore looks like this: high-rise, high-density residential districts. There are several layered efficiencies in Singaporean urbanism. One, efficiency of land use. Land scarcity in Singapore has driven the market to provide homes for as many as possible on the smallest area of land. Two, efficiency of mobility, which depends heavily on high-capacity public transport, although density also contributes to walkability and bikeability. Three, efficiency of program. Highly dense neighborhoods are able to support urban programs like office buildings, light industry parks, commercial centers, as well as amenities, community centers, food courts, parks, etc. This is some of the densest and most efficient urban planning in the world, but in the past year we have not seen special disruption due to COVID-19. Rates of transmission are low, and the mortality rate is the world's lowest. So somehow Singapore's residential districts are both highly dense and efficient without being particularly vulnerable to disruption from the current pandemic. I would like to argue that this combination of density and resilience is the result of an ongoing process of balancing between the need for density and efficiency and, on the other hand, human needs for living space, green space, recreation, and social space. Most of Singapore's housing is public housing, created by a government agency, the Housing and Development Board, or HDB. While the first housing created by the HDB in the 1960s was pragmatic and minimal, over the last 60 years a process of gradual adaptation to growing affluence, market conditions, as well as political and social circumstances has increased space per resident and introduced valuable redundant spaces. Living space per person in Singapore today is at almost 26 meters squared per person. This is in comparison to 19 meters squared per person in Tokyo or 14 meters squared per person in Hong Kong. Shared public spaces within buildings and adjacent to housing have expanded and intensified in recent decades. Mixed-use development within public housing has become increasingly common. Networks of public green space, bicycle and footpaths have been connected step by step to make a nationwide network. During a period of circuit breaker in 2020, when nearly everyone moved to remote work and home-based learning, these more generous homes compensated for loss of shared workspaces. And the green space networks, the active mobility networks, supported a surge in cycling. The COVID-19 pandemic has been an active test of the vulnerability of the Singaporean system of town planning and public housing in the past year, and largely it has emerged successful. But the subject of my team's exhibit at the Biennale is on a related challenge that Singapore faced in 2020, a challenge arising from an extremely dense, extremely efficient type of housing that showed dramatic evidence of vulnerability in the COVID-19 pandemic. In mid-April 2020, there was a spike in the number of cases of COVID-19 in Singapore. The disease had spread rapidly in migrant worker dormitories. Singapore is heavily dependent on foreign workers, in particular for the construction industry. There are nearly 300,000 construction foreign laborers working in Singapore today. They are housed almost entirely in dense communal housing, migrant worker dormitories. Singapore's migrant worker dormitories are concentrated mainly in the peripheral areas of the city, and they have been built to be as dense as possible. This group of high-rise dormitories, for example, can house up to 25,000 persons. Dense housing arrangements like these made it very difficult for individuals to self-isolate and halt the spread of COVID-19. In response to the outbreak, residents that tested positive were moved to temporary community isolation facilities. There was an additional push to create temporary quick-build housing, even for healthy workers, to reduce the density of existing purpose-built dormitories. As part of the government response to COVID-19, new guidelines were proposed for the migrant worker dormitories, with particular emphasis on de-densifying measures. The minimum area to be allocated per resident was increased from 4.5 square meters to 6 square meters. Beds per room were to be limited to 10, only single-deck beds would be permitted, and a minimum of 1 meter spacing between beds was enforced. In our discussions with dormitory operators here in Singapore, we encountered pushback on these points. They asked what numbers will actually reduce spread of disease. How do we know the measures are not too much or too little? These questions are inevitable and not to be dismissed. Any change to the way we build and live is not without economic consequence. And to make a positive change for resilience, we have to be prepared to answer these questions as precisely as possible. In 2020 at SUTD, we gathered together a group of professors and students to study the challenges facing migrant worker dormitories during the COVID-19 pandemic. Some of this research is shared in our display at the Seoul Biennale and in our contribution to the Biennale Data Book. Jung Kai, our building scientist at SUTD, completed a series of CFD analyses of existing dormitories, attempting to understand if passive ventilation is adequate to refresh air in dormitory rooms, and to locate areas of airborne virus retention in stagnant air. With my research group, we created a computational model of dormitory function to help architects understand how congestion occurs dynamically during the working day and to test how it may be reduced through design and schedule changes. Our team co-leader, Calvin Schwa, leveraged his architectural practice, anatomy, to test designs and details for temporary structures that could provide needed space for migrant workers. We reached out to NGOs working on healthcare and livability for migrant workers in dormitories, and with a group of students we conducted a survey of migrant workers to better understand their preferences for how their living environment might be improved. Together, we teamed up to design a worker refuge, a vertical framework, like a temporary circulation core, capable of being attached at any point on the facade in a high-rise, high-density worker dormitory, and providing extra space for seclusion, prayer, eating, space to make a private phone call. It was also designed to be a space with a high rate of passive ventilation, driven by stack ventilation, comfortable in tropical climates, and safer during the pandemic. The COVID-19 outbreak in Singapore's migrant worker dormitories ended by September 2020. There have been only occasional clusters since then. Public health measures, including extensive testing and careful quarantining of infected individuals, along with de-densified dormitories, contributed to the end of the outbreak. High-rise, high-density dorms are now filled only to 60% of their maximum capacity, down from 88% on average a year ago. The outbreak brought greater awareness to migrant worker living conditions in Singapore. There have been recent debates played out in the editorial pages of the Straits Times over the future of migrant labor in Singapore, if and how the country might reduce its reliance on foreign labor. Improvements in healthcare for migrant workers are also in the works, with 6 new medical centers proposed, and 3 meant to be located within large purpose-built dormitories. Let us return in conclusion to the opening premise of this lecture. Are dense, efficient cities invariably less resilient? From the cases presented in this lecture, we can move toward a better informed position. 1, high-density urban districts can be resilient, especially when additional investments are made in robust, redundant systems and generosity of space for residents, green space networks for recreation, space for active mobility. 2, very high-density living arrangements do seem to be vulnerable to external shocks, especially if they exhibit 2 characteristics found in the migrant worker dormitories that I've just discussed. First, these dense living environments were vulnerable because their design was over-specialized and had minimal redundancy. With little to no extra space or flexible space, there was great difficulty in permitting self-isolation or setting up medical quarantine spaces. In our interviews with dormitory managers, they emphasized the need for flexible space, not just more space, but also for the ability to convert spaces to different uses as needed. Design forethought needs to go into flexibility for resilient space. Second, the dormitories were vulnerable because their system of organization is highly centralized. If a dormitory had an active case of COVID-19, it was impossible to isolate or quarantine one area. The whole dormitory had to be locked down. While it is efficient for many workers to share a single large washroom facility, it is undeniably very vulnerable to disease spread. Again, while it is efficient for many workers to share a single bedroom, it is undeniably more vulnerable to disease spread. Design forethought needs to go into decentralization, strategies to create self-sufficient socio-spatial clusters at multiple scales, at the scale of the building, but also at the neighborhood or at the district level. Finally, the vulnerability of migrant worker dormitories to the COVID-19 pandemic was not just a question of density, shared toilets, and ventilation systems, but also of the affordances provided for individuals to be able to take reasonable measures to care for themselves. There is a human component to urban resilience, and it is lost if we do not provide the basic conditions necessary to support it. I hope if larger institutions, if governments begin to take a greater interest in resilience, that they invest not just in infrastructures, but also in people. A final closing point on the nature of resilience. The definition I've relied on throughout this lecture hints at an option for escaping the zero-sum game of trade-offs between resilience and efficiency. Resilience, in this definition, is a capacity of a system. Or, since we're talking about urban resilience, it is the capacity of a system of systems. If we choose to adapt the system, instead of struggling to maintain it as it is, we can achieve very different sets of inputs and outputs. Perhaps the only way to win the game of trade-offs between resilience versus sustainability is to choose to transition to a very different way of life. This is the bigger picture, and I look forward to discussion on what this transition should look like at the Seoul Biennale.